All right, we're live. Take it away, Rachel.
Perfect. Hello, everyone. Welcome to the September edition of the Audio Programmer Meetup. Thanks so much for coming to hang out with us today. We've got some really interesting topics to be discussing tonight and a diverse range of speakers. My name's Rachel Locke. I co-host this meetup on the second Tuesday of every month with my co-host Joshua Hodge. Before we get started, I'd like to thank our sponsors. They are Sonox and Focusrite. Thank you for your continued support and allowing us to make this happen once a month. I'd like to remind everyone that we've got the Audio Programmer Meetup coming up in November. The dates this year are going to be the 14th to the 16th of November. All the information.
Sorry, that's ADC, the Audio Developer Conference. I think you said the Audio Programmer Meetup.
Oh, the names are so similar. Yes, I meant the Audio Developer Conference. Yeah. We're not doing a 3-day meetup, unfortunately. No. Sorry for everyone that's now disappointed. Yes, the Audio Developer Conference will be the 14th to the 16th of November this year. And you can get all your information and tickets at audio.dev. And we hope to see you there. The diversity scholarships are now closed for this year, but thanks to everyone who shared those around on LinkedIn and on social media, I think that we got a good amount of people signing up to that this year, and good luck to everyone that signed up. Hope to see you there. I'm now going to pass over to Josh, who will introduce our first guest for this evening.
Yes, and before I did that, I just wanted to touch on a couple of things. So you're actually helping to give a workshop for ADC, aren't you, with Dynamic Cast team? Is that right?
Yes. I'm not sure if it's been officially announced, but I'm 99% sure it's going ahead.
It's on the public schedule, so I'll go ahead and.
Okay. I didn't see that.
Slow launch.
Oh no! Now I have to commit to it.
So yes. Can you tell us a little bit? Can you tell us a little bit about that?
Yes. So I'm part of, what would you call it? Maybe a collective called Dynamic Cast, and we're based in Berlin and in London. I'm part of the London edition of Dynamic Cast, and we run monthly meetups that are focused on C++, and the main focus is increasing diversity in the C++ industry. And we run meetups for underrepresented groups to come and study in a safe space where they can talk about what they want to learn and share their experiences. And we discuss topics every month related to some C++ concept, and we code together. It's really fun. And I do that with my co-host, Harriet Jury. She's currently working with Jules and Cesare at Soundstacks. Is that right company? Yeah. Cool. Yeah. So we actually both did the same masters, and we met last year at ADC through the diversity. They had an evening event for the diversity scholarship attendees, and we met there, which is really cool. So some really good things can come out of ADC. It's a really good place to network, and really cool things like Dynamic Cast can come out. And moving on to what's happening at ADC this year, we came up with this idea along with Anna, who used to be working with Ableton. Some of you might have met her at ADC or otherwise. And she was running the Berlin version, or the original, of Dynamic Cast. And we had this idea for newcomers to the audio programming industry, that the focus this year on workshops, there would be a portion of the workshops that would focus on welcoming newcomers, and we would cover some specific concepts like software engineering and DSP. And me being more on the DSP side, I'm going to hopefully deliver a workshop on some introductory DSP concepts, and maybe we'll build something as well. And yeah, I think Anna and Harriet will focus a bit more on software engineering practices, perhaps C++ related, because it's more widely used language for audio. Yeah, really looking forward to it.
Nice. Yeah. There's a really exciting program that's on that they have for ADC this year, and you can actually find it. I believe that the schedule is on audio.dev/schedule, but if you go to audio.dev and at the top there is a tab that says schedule. You click on that and you can actually see the schedule up to this point. And it's a really great conference. I'll be there, and it's going to be from the 14th to the 16th. So as Rachel said, that first day will be workshops, and then the following 2 days will be the actual conference itself. And it's a great opportunity if you want to meet other people who are also in this industry or looking to get into this industry. It's a very welcome conference, and I can't champion it enough. So hope to see you there. Before we go into our first talk, just wanted to also give a couple of announcements. So first thing is, if you're not familiar with our Discord group, we now just broke over 8,000 people in our Discord. So it's people from all different levels and all areas of audio software development, and it's really awesome to see this community grow. And if you're not part of it yet, I invite you to join, and you can join us on the audioprogrammer.com/community. We also have a jobs board, so we help audio developers to find jobs and companies to link up with audio software developers, and we have some really great clients, and you can find out about all those job opportunities and contract opportunities on the audioprogrammer.com/recruitment. And one more announcement before we get started. The Audio Programmer is going to be starting a wiki. So in our Discord group for years, people have been asking us to have to start some type of website that has a common knowledge base for people that, because many of the questions that people ask are sometimes have already been answered in the past in our Discord group. And so this is a way that we wanted to be able to allow people to document something in place. So when somebody asks a question that's been asked a million times before, we can just send them to that link, and it'll have it'll hopefully over time become just a cornucopia of audio programming tips and advice and best practices. So I will have the link for that soon, and it'll be a great opportunity for people to be able to contribute their advice and also to find out more about audio programming, and I'm really excited about it. So with that, we will pass the mic over to myself, because I'm actually going to be doing the interviewing along with the Modalix team. So we have Igal Amir and or Lubianiker.
You got
it.
Yeah.
Yeah. Did I get it right?
Almost.
Lubianiker.
Yeah. There we go.
Lubianiker. That's it.
You did it.
And they're part of the Modalix team, and they've created a new product that's just come out called Beat Scholar. And I thought that it'd be really interesting to have them here on the Audio Programmer Meetup, because so many people come into our Discord and they ask about this process of creating their own company. How do we take something from from a prototype or something that they may have developed in university, and take it and build a company around this and release it properly as a product that is able to work across all operating systems and across all DAWs and the challenges that are around that. So it's been fascinating, and I'm really proud of Igal, especially because Igal has been here with us at the Audio Programmer from the very beginning. From the time that he was actually working at Waves. He was I think he was the first podcast that we ever had for the Audio Programmer, and watching him grow from a developer at Waves to Then he went to work with Steve Duda over at Expert for a couple years, and then he decided to spin off his own company. And watching his growth as a developer as well has been really amazing. So I'm super privileged to have both of them here to discuss these things, and I hope that you find it as helpful as I do. So enough of my rant. I will pass it over to you. Can you tell us just a little bit about, so I talked about Eyal a little bit, or can you tell us a little bit about your history and your journey into the industry?
Sure. I mean, the story is kind of combined at a certain point, so I guess that point would make a good segue to how we started the company and everything. But basically, I started out as a musician, a bass player more specifically. It's a big guitar with floppy strings for those of you that are not sure. Anyway, yeah. So I've always been interested in music and technology, like as an amateur, you would say. I've always collected pedals and all sorts of things that make weird sounds, and I was curious about how to combine them and make them work together and all that. So I've always had a sort of affinity to it, you can say, like a knack to figuring stuff out. But I've never quite learned anything traditionally, and I guess we're kind of similar in that sense. We're driven by curiosity. So yeah, fast forward several years after touring with artists around the world, mainly a lot of high-profile guitar players and people like that. I don't know if I should name drop if that's good for the podcast, but
yeah, go ahead, name drop away, please.
People like Marty Friedman from Megadeth formerly, and Gus G, who played with Ozzy Osbourne, and Ron Thal. Yeah, there's a list somewhere, probably online somewhere. But anyway, after years of doing that, basically, I think I met you maybe after my first tour is when Eyal and I met, and he called me up. I was a fan of his way before he knew me. And this is like talking about like almost 10 years ago, way before we even considered starting a company or getting into the software business. So at a certain point, he just, called me up, and I was feeling like I was watching his videos and thinking, why am I not in them? I was so like jealous because he had this amazing band or online project called Project RNL. So at a certain point, he called me up and was like, how would you like to audition? And I was like, well, I can make some time for that. And secretly, I was like ecstatic. And like from the first, it's a sort of a love story. No, from the first moments like we met, I was like, okay, this guy totally gets it. Everything I talked about before, like he's a researcher. He looks for the deepest part in like everything he's doing, and we kind of clicked immediately on that, on the musical side, and then in like, I don't know, dozens of hours of conversations just about everything. So from that moment on, we kind of joined forces around everything we could, work out to do together, whether it's a musical project. It was mainly music at first, but anything I needed help, Eyal was like the first phone call, and I guess it was the same. We kind of started collaborating back then. And should I move on to Waves and all that? Okay. Yeah. So I guess Eyal was contacted by Waves at a certain point because he was, while we were doing the band and everything, he made a name for himself, being like combining like cutting edge technologies and making interesting music with them. So he had a contact at Waves that kind of brought up the idea to do something together, like with Project RNL, which was at that point mainly the two of us kind of running the production side of things. And Eyal wasn't sure what to do, but at a certain point he came up to me and said, how would you like to come with me to a meeting at Waves? And I was like, I barely knew anything at that point. I mean, I knew it from like being a bystander and watching Eyal work, and maybe I had some chops, very basic production chops. And I wasn't really sure what would come of it, because at a certain point, like maybe a lot of listeners would connect with that. Like sometimes you're so sure that you're meant to do something. For me, it was playing bass for a living and having my life be around that. that you have this huge opportunity coming and you don't recognize it at first. I wasn't immediately like, oh, of course I want to make plugins. Of course, I was like, what the hell? I'll come to the meeting, and that kind of ignited that part of our lives, which became very central at this point. With Bass Slapper, which was the first plugin that kind of we got thrown into the deep end pretty quick, and we had to figure a lot of stuff out. But I guess maybe I can let Eyal talk for a second.
Yeah, the story of Bass Slapper is a story that Eyal told me a couple of years ago, and it's one of my favorite origin stories when it comes to
I like that.
How they get into the industry. So maybe if you could recap that story, Eyal, just how you got into software development, how the creation of this plugin, because you weren't even programming at the time, were you? You weren't even developing.
Yeah, I wasn't. Yeah. That's so true, and that's how my path with OR is actually kind of like very very parallelized. How do you say
parallel?
Parallel,
yeah,
parallel,
yeah.
Right? In the sense that, So I don't want to go too much into this because we have so much new stuff that we're doing now. But So what happened was, we got this, offer to develop a product, and then Or and I started to come with all these ideas about like a smarter kind of instrument. Which actually is really connects to what we're doing today and everything. So we had all these ideas for how to make something feel like it's played, right? And we kind of pitched that, and they liked it, but they had no idea how to do this. And I kind of volunteered to do the programming part of this, even though I had no idea that I can actually do that. It was more of like how do you say it? It was almost like I wished that I could do this more than I could really do this, and that's how we embarked on this journey. Because on these two plugins, Bass Slapper and Bass Fingers, that we made, Or and I together were like learning so much, because I was very deep into the programming, but he was like sampling and designing sound effects and helping us, define what the instrument is and how you would play, a bass-like instrument on a keyboard. So we both kind of gone through a process of doing this, which kept on for a few years with a few like detours, I guess, in the middle.
Yeah, I mean, I at a certain point after Bass Fingers, I stayed with Waves to develop both first software and then hardware. Actually, I was doing like hardware development for a couple of years, and Eyal was doing other projects. But we always had a sense that at some point we're going to sync back up and pick things up. And what he said about like the process with both products we did for Waves, Bass Slappers and Bass Fingers, I guess like it really planted the seed, for not only our ability to make something, but to like for us to kind of write our manifesto around instruments and that world in general, So we had like, even though we always felt like a strong feeling of ownership. We didn't feel like we're doing this gig for Waves. We always felt like this represents us. This represents what we think about about that world. So it kind of, I liked what he said, like that, it made me realize, what we're doing right now, even this product we just released called Beat Scholar, it's out right now. Even this product is a sort of continuation of that same area of taking like how musicians think and comprehend music, and then kind of finding a way, an elegant way to represent it, like both visually and in terms of user experience and all that.
Mm-hmm. That's awesome. Can you tell us a little bit about the way that this goes from an idea for a company or an idea for a product into something that you can actually sell to people, and just some of the challenges that come along with that? I mean, I'm sure that we could probably talk for a couple hours about that, but can you just give a brief overview maybe some of those first discussions, what those were like, and what some of those first steps were. So I've got a great idea. Cool. Let's go do this. Okay, what do we do? What's the first step?
Yeah. So maybe before we go there, I'll maybe we'll show a bit of BeatScholar and what that is, and then we'll go back to the beginning because we have a little bit of like a timeline of things that happened in that process, right? So let's do some screen sharing here. Okay. So we got some screen hopefully happening. And this is BeatScholar. The preset is actually called This is BeatScholar. And this is the init preset. I'm just going to hit play, see what happens. Now, let's hear something else. So these are like a few of the presets that just come with the thing, and hopefully, as you've seen, it's a drum sequencer, drum composer of sorts, with a lot of cool rhythmic and visual things that I guess you can do with this. And as you can see, like the timeline is kind of expressed with all these like circles or pizzas, as we like to call them. And a lot of the process we try to put with this is to visualize elements and also to make them like really, I guess, easy and quick to write. So for example, I'm just going to do something pretty quick. So let's say I'm starting with like this blank slate with the init preset, which is just like 3 rows of 4 circles. And you can just like pick a drum. Right, this is a kick drum, this is a snare drum, and I'm literally just triggering them with my keyboard. So, right, I can just play the different notes.
Can I pick a kit?
Yeah, pick a kit.
I'm sorry for interrupting. Give us a new kit. Let's go for a classic like
707.
Yeah.
All right, and then we can just take a drum and put it somewhere in time. So, for example, the kick drum here, right? And let's add a snare. And let's do something more interesting. Let's put some hi-hats in there, right?
It's a hit.
It's a hit, right?
I'm telling you.
Right? But this is pretty boring. So why don't we like split this into like 8 notes, right? Right? And maybe put this all over the place, right? I guess better. Maybe we can put something like a triplet in there. Right? And maybe I want to put something like a big freeze of like, I don't know, this in there. And maybe I want to put this thing in 5/4, right? And I don't know, copy this here, change some velocity, duplicate this, do a few other little slices here. Maybe add some weird swing. Right? So the idea is that there's all these like little quick ways where you can do editing, and you can go like pretty deep with time signatures and subdivisions and sounds and everything like kind of like pops out of the screen in terms of like visuals and everything. So this is like this is really a lot about what we're doing now. Here we go. You can make like really long presets, then you can like kind of scroll right through the timeline and zoom horizontally or zoom vertically if you want to zoom on that axis.
You can also see here, I opened this preset on purpose because it has another like kind of paradigm shift. Okay, so. So it has another kind of paradigm shift, which is you can place on any beat, you can place drums, like different drums, which in the standard kind of step sequencer paradigm, you have lanes, and each lane is devoted to a certain drum, and that's how you kind of place drums within the timeline. That's very standard, but we figured, and this is again the thing of like how musicians kind of conceptualize music. Sometimes rhythm is not just like independent points, you know, that kind of happen to be next to each other, independent drum hits. It's phrases. It's different notes that kind of come together to represent something, you know, different. And each color here is a drum. I guess you're sharing screen right now, or
No, I just stopped the screen to have you there.
Oh, awesome, cool, way prettier. Each circle represents a beat, and it holds several drums, and then you can kind of create you have this freedom to kind of represent how you feel the beat. If you feel like the kick and the snare are really tied together in some relationship, you don't have to have them like separate. They can really live on the same lane. And there's even like do you mind if I reshare for a second? Yeah. There's even like presets that kind of give an example to that. So there is one we have a tutorial folder in the plugin, which is a pretty fun way to get to know the plugin. So this is an entire beat. I'll just play it, and you'll understand. So this is an entire drum beat in a single file, like a single lane of circles. But then if I wanted to split it to different lanes, it would look like this. So there's always, sorry, yeah. Just so I prove that it's the same. Oh. Yeah. So it's the same beat, it just represented in two different ways, like a more traditional way, which each drum is represented on a lane, and then our way, which is kind of more compact. And this is also very common. If you ask two musicians how to play something, they will give you a different answer. So we wanted to like get a product out that has, and that's kind of I think an interesting topic to discuss. Like, what is the amount of freedom we want to offer users and musicians to kind of be individuals, you know, not just to present them as this is how to do something, and if you don't do it like this, you'll get a bad result. So this is kind of what we came up with, and maybe we can do the circle back thing and start from how we came up with the system and everything.
Yes. And yeah, and so back to Josh, what you asked. So this is like I guess you could say an end result of sorts, even though we're still improving and updating Beat Scholar every day. But back to where this whole thing started, right? So let's switch back to, I want to say about 8-9 months
something
ago,
like that, yeah,
or something, and we were prototyping a bunch of ideas. Right, so Or and I would just like be very, we would just be very deep in the research part. We would just spend all day like talking and conceptualizing, and Or will show you a few of the like early sketches I think that we have of Beat Scholar, because some of the stuff was just like, hey, let's put something on the screen, right?
There we go.
Okay. So this is sketch number 1. It's just circles on the screen. We had no idea we wanted to split the circles just yet. We just knew we wanted something circular, right? Or came up with the circular idea. And
just because circles are nice,
right?
For no particular
round
reason. Yeah, they're very round, and yeah.
And we had these, like when we started, like it's funny, when we started we called them like M&Ms. Right, and then they became pizzas, and there's a common theme here in our development process, that we eat a lot.
That we're hungry constantly.
Let's look at a bit of it, and you'll see that our idea will slowly develop. Like we'll iterate a lot over something. Like we'll iterate over concepts, and then we'll kind of design them and program a little bit of like just the basic functionality, so we can get a feel, and then we'll go back in another cycle, right? So because almost each group of these is a cycle, right, that Or and I had, because it was like he would say, hey, what about this, right? He would prototype this. We're going to see later how deep his prototypes would be. Like sometimes his prototypes would even have some like interaction on the screen and things moving and display things in a certain way, right?
Yeah, I guess that's a kind of a strength of ours, I'd say, that and it relates to your question at the beginning of like how do you start a company, how do you go from an idea to a product. We have this dynamic between us that we don't get hung up or stuck on ideas. We kind of prototype and we iterate, and we do it as fast as we can. Like we don't like to leave stuff for later. So what you saw earlier, a bunch of shapes, we had we were just talking in abstract, like how do you visualize rhythm in like without notation. And then we started to think about shapes and numbers. And then you saw this really ugly sketch, which is just a conversation of ours with me with a laptop on my lap. And I'm drawing shapes and counting the amount of angles. So, and then we didn't like that because it's not uniform, and it would result in like a mess on screen. And then, fast forward like a couple of days of just making prototypes, talking about them, and while I was doing that, Eyal already was programming like the first idea with the small circles, the M&M idea. And so while I was kind of ideating and thinking about the next phase, he was already kind of implementing, and we had like audio playing, like drums playing in his prototype. So we have this sort of process where I would be working on the next step while he was programming something for us to test that we were talking about, because that sometimes drawing on screen is really nice and pretty, but then putting it to code is a whole different ballgame.
Right.
So it's really fun to draw a bunch of circles, but then somebody has to eat the vegetables, as they say, and kind of go through the process.
I like programming. It's fun.
No, but I'm just, referring to the amount of time that I spent drawing circles and then the amount of time you spent making the prototype that actually plays and reacts. I actually got a little bit into that in our process, but we'll maybe get to that later. I got into eating the code vegetables, if that makes any sense.
So he got you coding then?
Yeah.
Wow.
I caught the bug at a certain point.
Amazing.
Yeah, because what happened with Or was so cool, because we were seeing it first, and he was designing the things at first. But then, just like the way we'd work when we would produce music together, is he wanted to get into like the detail of things, right? We would write some DSP or some effect, and he would say, hey, you gotta let me calibrate this. Like I want this to sound a certain way. So I'm like, so at first we started with like back and forth where he would tell me, hey, add more gain stages and whatever. But then I'm like, come on, this is not gonna work. Like you should have the thing in your hands, and then you can make it sound like you like. And then we've had this like iteration process where I would show Or like the basics of how the libraries are built when I do some sound design things. And later the UI, and he just went in and figured it out.
That's being simplistic, because Eyal is kind of, I don't know if it's out of modesty, but the way his libraries are set up is perfect for somebody like me, because he was basically he made it so he could have like a quality of life, right? So everything is it has perfect aesthetics, and it has internal rules that are probably like just great practices for coding in general. And then like combined with I had this feeling of, okay, how hard can this possibly be? Like with everything I've done in my life, like it's okay, I can learn how to move a picture from left to right on screen, or calibrate a signal chain, or like understand how it's represented in code. Like it's not, I didn't feel like that would be my limit in terms of comprehension and intelligence. So, and then combined with like Eyal's ability to build the tools that we use to develop, it was something amazing to see, because sometimes there is an advantage to being like not from the field, because you kind of think about things in a non-traditional way. And I would ask like, hey, why don't we have something that does this? Like in terms of, why don't we have a system that makes it easier to perform UI tasks? And then he thought about it for a second. We went back and forth, and like from the designer, I was playing like the designer, and he was like and we negotiated, and we came up with a system that enabled me to basically take on all the UI tasks, which is terrific because Eyal was in the much deeper coding of the sampler and the sequence area and stuff that's above my pay grade. So it created this really nice feeling of capability with me. So I wasn't like dependent on everything. Like when you design, you have to kind of sit and wait and then see something and then comment on it. I didn't like that as much as I do, like, doing the design and then coming to Eyal with something that's like actual, that you can click and it reacts. And, getting into that was amazing for me. And he made it so easy that, it was kind of a shame not to.
So I have so many questions. One of them for me is just going a little bit deeper with that learning process. Can you talk a little bit about that? What that was like for you? So did you find yourself digging through C++ books or going to C++ tutorials, or how did that process happen for you?
I'm sorry, I'm such a bad example. Not even one, I guess. But I had like the best teacher on planet Earth as my business partner and close friend. So he went through books and all you guys probably know, like he went through everything. So, and it's also a matter of like wanting to get the product out in time. That was my priority. I understood if I have to ask about every pixel, our time to market would be impossible. And, the company has to have a product out and to be financially viable. And that's like something very important, So that was it came out of necessity, and then I was drawn in by the feeling that this is endless potential, and I felt so like everything I managed to master had this immense feeling of gratification. So I learned like in very small layers, but it all came from, okay, he's really busy with something. I need to understand how to make a pop-up menu and to connect it to these parameters. So I would kind of take bite-sized chunks, and every time I would ask him like kind of deeper questions. So the learning process wasn't books and hours of here, read this and come back to me. It was always there was always a small result at the end, which we feel like is, I guess, how we both like to learn. There has to be a product at the end of the process you're doing in order for it to be a successful process. Even in music, like we don't like to compose without ending the day with a small file that we can listen to, so it's kind of the same thing.
Yeah, got it. So it's learning out of necessity to get to the next phase more than anything. Is that right? I'm not able to be genuinely curious in any other way in my life, which has also disadvantages, but that's just how it is. I think that's the way that a lot of people learn. I mean, it sounds like that was a common way for you to learn as well, Eyal, just from Bass Slapper, was that you have this thing and you know what you want it to be, but from a programmatic perspective, maybe you didn't know how to get there. And so these things became necessary steps, necessary things that you had to learn in order to get there. So it became very much a practical exercise rather than theoretical and just digging into books and learning about multi-threading without any type of context to attach it to. Does that sound right?
Yeah, for sure. And that's also something that we're trying to implement as like a general practice. And I think it's a good practice both for learning code and to, get a product out, is we don't try to do everything perfect the first time. Like you've just seen like a few of our early sketches. There's a lot more. Like we don't go out to do something and say, okay, we're gonna program this. The code is just gonna be perfect. Let's make the perfect design. Let's know all the answers to talk about like code design, right? Like it's gonna have like the perfect multi-threading support, and everything is gonna be perfect. So we don't do that. That if we would we would do that, and that's something that happened in some projects that I worked on, unfortunately. And that's how you like get in like loops of not getting anything done. You're like you're obsessing about things, about getting things to be perfect in terms of like being technically correct, and then you don't get anywhere, right? And so what we wanted to do with Modalix in general, I guess, is we wanted to have like quick cycles where we do something, we review it, we find out what worked, right? Even technically, right? We do something, we say, okay, this system doesn't work. This system is not very solid. Maybe there's bugs. Maybe it's not like easy to write because it's complicated. That also happens, right? We would make a system, and then we realize that actually getting the system to work is painful, right? We would have to like move things from here to here, and there'd be a lot of like boilerplate code. And they're like, okay, we've done the cycle, we've tried this way. Now let's go back. Let's try another cycle of making the process shorter, right? And we would analyze like what's stopping us here. Is this because the calling convention of the code is confusing and we always have to think too hard about this thing? Okay, let's break it down. Let's find out if we can write a shortcut for this so that it becomes like a pattern that we can kind of reuse and not do the same thing and get stuck with the same bugs every day. So a lot of what we're trying to do is have this like feedback cycle where or would come up with this idea or some design idea. We'd start to implement it. We'd see what are the challenges technically. Is this working immediately for us? Like, is the idea responsive? Is this like an idea that spawns too many side quests? Because that happens sometimes in both programming and design, right? You're drawing something on the screen or you're coding it, and then you're like, okay, to do this correctly, I'm going to need to write like 50 libraries and like I'm going to need to like read books about like complicated DSP, and then you're like, okay, do I really want to do this just for this feature? Is it cool enough?
Or even is this the timing to do it?
Right.
Because sometimes you think, okay, this is like big picture stuff, but right now in order to get from this point to the next, I don't need to calculate the problems of like 6 months from now. And sometimes that stuff kind of stops you because you're like stumped, you're like intimidated by the size of some task, but then you kind of have to have this, for us it was each other, this grounding, somebody or yourself to go like, hey, listen, this is like problems for 6 months from now. Today we just need this to work, and maybe we can show a little example of maybe the circular controls, which was our early experiments into how basically where do you have it? I'm gonna show you like my not this one. Well, this is the second phase. The first one is the beat scholar animation, the first one. So this is like me sending Eyal a video from a prototyping software. So I was experimenting with like what kind of interactions you can have with circles on screen. And it was me like, there's some faulty animations here, never mind that. But it was all sorts of ways to determine velocity and notes and with different areas that you hover on, and they show like this is splits the slice into two. And then this is just me showing off that stuff is working. Never mind. So this is an idea. So we decided to have a cycle on what became circular controls. So this is an initial idea. So we have this conversation for a couple of hours, and then I sit in front of my laptop, he sits in front of the code, and I design and he programs. So immediately afterwards, like talking about hours after Eyal sees this, he sends me something like this.
Right. So this is like a juice version of these controls, right? Where you have like, for example, a slider that goes here, but you can also do like a drag between the different slices. And then here you got like more of like a toggle, right? It's more like a button. And I've made it in a way where you can kind of stack them together in the same circle, just with different radiuses, right? So that they in terms of like the slice, right? The slice is shared. So this and this are actually shared in terms of whatever notes or drum they represent. But then each like layer of this is its own, I guess, part of the properties of the drum. And then do we have the more advanced one here?
I wish.
Oh, no?
We had a version with like I can show it in Figma, but
this maybe, right?
Oh, yeah, this is another version of the control. So we were experimenting. We didn't even know what we kind of experimenting in an abstract way. We weren't sure like what will be velocity, what would be notes, what like we were just thinking like what would be like a good time to make, to interact with the software. And we were thinking that, okay, as soon as we figured out the slices and the toggles, we were like, this is a good time. This is nice, kind of toggling stuff on and off in a circular control was fun. But then like for velocity, we don't have that nice little piece of software. We realized that we can do like a sort of a fake sense of distance if we just add shadows and kind of a gradient of the color, what do you call it? Like the color gradient. So red becomes a darker shade of red, and then the other slices cast a shadow on it. And this was something that we were very excited. The second we figured it out, we were very excited, and Eyal had to sit down and kind of zone in on how to do that well, how to cast that shadow in a convincing way. So this was kind of a fast forward of our cycle, just talking about nothing makes a sound yet. We're just talking about how to control and kind of imagining, okay, if this would do velocity, would it be effective? Would it be fun? Would it feel like, like it's doing velocity basically? And this is kind of an example of what we're talking about, of how we work. And this happens sometimes within a day. Like in the morning, we have the conversation, and at the like 8 o'clock, just about now, we would be sending each other like remarks on the prototype.
Nice. And so were you doing your prototyping mostly in Figma then? Or what were you prototyping?
Yeah, mostly in Figma. I developed the entire design and UI in Figma, and my wife Tal helped me a little bit with Illustrator. She's also a terrific designer, and a small company, and we're bootstrapping, so it's nice to have all the help we can get. And she's really wonderful. Hi, Tal. Yeah, so it's really comfortable because I can like export all the assets in seconds in whatever format I want, and I can do the prototyping thing, which Eyal really liked because it kind of gave him, I guess, at certain points where the going gets tough. So sending him a nice prototype that has nice animations and seeing him like get excited about ideas is, I think it's a powerful tool for any product manager or company owner to kind of, have something that shows an endpoint in a very convincing way, because it brings everybody, even myself, it kind of gets me riled up,
Yeah, absolutely. And can you talk a little bit, Eyal, about that process of making that Figma document, or that Figma idea into a Juice UI, and some of the challenges that you encountered there?
Yeah, sure. So there's a lot going on there in terms of the UI in BeatScholar, and it's not like or send me this image and I was implementing it. It was more like each little thing, each circle or each knob or each menu or whatever was like developed over time as we were experimenting with things like which controls should it be and everything. So a big part of the way we were able to do this is we have this design where we keep a very strict kind of separation between what we call the state of the plugin and the UI. And in Juice terms, right, that means that the everything that the UI is doing, like for example, if there's a slider or whatever, then the slider does not interact with anything related to audio. Never. Like the slider doesn't know anything about audio. It's the slider is controlling an abstract parameter, which could be an audio parameter, but actually could also be other things. Could actually be, if we're talking about like the velocity of the drum, right? Could be some abstract value that goes into some data structure far away. And we had to keep this because a lot of what creates, beats color is because a lot of the data is super dynamic. You can have an infinite amount of bars on the screen. Each bars could be different time signatures, and the lanes are spread out, and the drums can be different in each pizza. And the idea is that a lot of it is completely dynamic, right? There's a lot of these different options, and for that to work in a way that's reliable, that actually doesn't break every second, you have to make like really strong boundary choices. You have to make sure that the UI only knows about these certain parts, right? So the way for example, we've done this is we have this thing that we call one of the things is that we call this thing a parameter, and a parameter is not the audio parameter is an abstraction around a value, and that means we can create, for example, things that are generic, like something that that has the movement of the slider but doesn't show anything. It's just something that moves from bottom to top or left to right. It just has the movement, and it can control a parameter, but it doesn't show anything because the display of this could be a knob, could be a little pizza slice, could be what else do we have that's a slider in the
We have the reverb knob, which is another kind. So this separation kind of makes everything very like able to morph. Like we can come up with controls very quickly because of this system, because of this method. So if we have an idea, we already know what goes into it. So you basically move the mouse from somewhere to somewhere, and that part is taken care of. We just need the drawings. So we either just draw it in code, or I deliver like some sort of SVG, and we go that way. But yeah, what Eyal mentioned now is like how we were able to prototype things very quickly is just having these systems, multiple systems in place that make these cycles like the one we showed with the circular controls very quick. So there's no additional development. Our general rule of thumb would be, if we think this is something that is fundamental in our development system and our conversations, we need to take the time, like don't be lazy. We need to take the time and make sure this is never a setback. And I guess like if you do that enough times, you're left with like a pretty solid development system.
Yeah, and so there's a few examples, right? So one of the things we wanted to do is, first of all, we wanted to have a fully resizable UI, right? So that you can just stretch it to any screen and it will work with like big, 6K monitors if you want to, and it will also work with little laptop screens, and you'll always be able to fit it. So we'd have to write the thing so that everything can be totally resizable. But then we were like, okay, when you start to have a ton of bars on the screen, right, then you'll see that suddenly I can start adding bars here, and you can see that the shape starts to change as I'm doing this. And then when I'm going to add more, right, if I'm going to start zooming in, the zoom is actually now the zoom can actually reveal a few of these buttons. So for example, if I do this, right, suddenly the duplicate button shows up, because even though it's resizable, only certain zooms will work for certain amounts of bars. And same with what happens vertically, right? If I'm going to start adding buttons here, at some point, buttons will start to go away so that they're more static, and then you can zoom back in to bring them back. And this only works because we have this very kind of like a layer separation, so that each little bit of this is handled with something that's shared across the entire UI. For example, making something stretch, or making something resizable but with different variations for each zoom or size. So all these stuff are generic concepts that we have in our library. We didn't code those specifically for the bar section or whatever. We coded them for as something generic that can work with any kind of components and any kind of things, because we wanted our entire UI to behave like this. So a lot of what we would do in terms of like getting technical is we have a lot of juice modules that we wrote for our system, and some of these have to do with, I don't know, DSP and the sound area, and a lot of them have to do with UI interaction with the state. Like the UI has a behavior and it touches a state, and now if you write it generically enough, you can now kind of compose different kind of interactions with different kind of state, which is actually really cool. Like you can, that's something really fun we do a lot when we'll kind of prototype something, and then we'll like, okay, let's make a list of a lot of those, and then let's connect this to these pieces of state, and immediately the UI becomes really dynamic, and that only works because we really like we have these like iterations of how UI interacts. Like if we have this thing where you have to code too much manually for the UI to be interactive, we iterate over this. We write a library object that will kind of do this for our entire UI, and we think of what it means.
Do you want to show the JSON thing?
Oh yeah.
We have a pretty cool like example of what we're talking about, like a very visual example you'll see, which is basically a conversation we had about how to make the visual iterations way faster and to give me a lot of freedom in terms of how I design the UI and how I move around objects. And there's a system we have that allows us to basically not rebuild every time we're doing something like that. It just kind of, you'll see in a second. I'm just trying to burn enough time until Eyal creates the object that he needs. But yeah, I think it will work right now. If he relaunches Beat Scholar and shares the screen, we can show you something really cool. So yeah, you see, let's put some kicks and snares on screen. Just a very quick example. And if he opens a JSON file called colors, and then looks for an article called kick color. So now change it, put blue on 200.
Right, so let's have them both on the same,
yeah.
So we can kind of see them. So this is blue, right?
Blue on 200, and kick is the red drum, and it becomes a nice shade of, this is pretty cool. So we have this for 3 different categories. We have this for colors of almost all elements you see on screen. We have this for the position and dimensions of every element you see on screen. And we have this for what we call constants, which is, if he opens that file, you'll see also something cool. Objects that get replicated across the screen many times, we can put in a file called constants. So if he takes beat slice stroke and makes it 3, you'll see that the boundaries of every, so that's actually also pretty cool, but it wasn't supposed to happen. Yeah, you know how it is. So 2 would give us a thicker boundary around each circle.
Oh, that's fine.
Yeah, 3. Okay, there we go. 3.0 it needs to be, or 4.0. So just imagine that as a person designing a plugin for the first time in my life, this is a dream come true because it gave me so much control over everything.
Wow.
And then it's live control. So I don't have to rebuild every time. I just, I need to create this infrastructure in the code at first, and that's what I learned. That's like was my introduction, that and some DSP. And then I could basically follow through from designing in Figma to showing Eyal, like, here's a bunch of buttons and it all works, and we just need to connect it to parameters. And you can imagine for him it's like a sigh of relief that that part is taken care of. And I think this is something really cool, because the system was developed after we were talking about, like, how would we want to interact about UI.
I'm just putting random numbers in there. I'm making it.
Yeah,
sorry.
This is terrible. Please stop. We need to dish out an update, and I'm super scared. Anyway, so yeah, this is a visual like representation of what we're talking about when we say working on your tools, like not being lazy. Like, we need something. This is pretty like advanced stuff for us. Like, we never did something like this. But we took the time to do it because we ended up saving, I guess, hours, if not weeks of work, because we spent several days doing this.
So is this using juice live constant under the hood then, Eyal?
No. So juice live constant is a similar concept, I guess. This is using my stuff because it does all kinds of other things under the hood. For example, when we're resizing things, we have the thing where we want Or to be able to put in his like the dimensions that he would see in Figma, but the system would translate it into something that's stretchable, so it would have like a transform and would actually work with any kind of size. So it's not just like plain numbers. It's got like there's some logic in there for some of the things with how it interacts with our system. So and then the cool thing about it is that when you like this JSON file, it actually goes into the product. Like this is what's in the product. So we just bake it in the product at the end. So whatever Or is developing with the thing, that it doesn't have to go and retype the numbers back into code. Right? We can just put the actual like description file in the product.
Wow. That's amazing. That's amazing.
Yeah.
Can you talk a little bit about, so actually let's ask a couple questions from our audience here. So one question that we have is, do you prototype in the same tech as the production version? So has this always been in juice from the very beginning?
Yes. But obviously Or will prototype in Figma and we'll sometimes mess with other environments, but generally I don't like the idea, and this is actually something we've tried. So I don't like the idea of having a separate prototype environment because I feel like a big part of what we're doing is saying, okay, let's make this good enough to actually use this and actually try the thing in context of a usable product, I guess.
Yeah.
So the way we like to work is we write, like I said, a lot of juice modules for things. So let's say we develop a new effect, something that happened with this. So what we would do is we would have a juice module that would just be the effect without the plugin, just the little thing that's the effect. And then we would make some, like the most basic UI for this, maybe a juice generic processor editor or something that would just like the most minimal UI that can be done for this. And then we would have in our system a plugin that's just this, right? Just generic UI and loads that exact module, and then we would say, okay, this is it's not perfect, but it's good enough to have it tested. So we will just load the same module into the real product. So now the little plugin is almost like something that we continue to use. Because we will iterate over this effect. It's not going to be perfect at first. So we would listen to it, we would try it with the real product, then we would say, okay, this is not good enough. Let's rerun this, and we can now test this and use this and even send it to our friends sometimes outside of like the big complicated plugin. And this is something that's really important for us, right? Because if we had to re-implement this, if this was like a Python script and then we say, okay, this is now pretty cool, let's re-implement this in the plugin. Oh, it's not good enough. Let's go back to the Python script and change that.
Right, there's like a sense of continuity also.
Yeah.
Like we're constantly refactoring and improving. And sometimes, we understand, like Eyal said in the beginning of our talk, sometimes you got to do something dirty for a second just to get to the next step, but we never leave it like that. We always go back and using the fact that we're constantly using the same platform to do everything gives us a strong sense of control by the end of a process like this, where we know every pixel and every parameter where it sits. Okay, sometimes we need to search, but basically we have this sense of continuity. I remember, we both remember how stuff got developed, and we have those traces, but we try to have them organized. We don't leave we don't leave the original prototype that was written all dirty in the code naturally. But yeah, I guess that kind of answers the question.
Dimitri asks if you use a different juice component for each pie in the circle? And do you use if you use the juice viewport to handle the scrolling in the window, or is that all something else?
Yeah. So each not each. So technically each slice is a component, but it's not a real component.
Got it.
It's hard to explain. But basically you can say, if you want to think about this, is that we kind of had to override a lot of the juice system to do this, because the juice system, in terms of handling stuff like mouse events, is not exactly how this works. So let me, I guess, share to explain. One of the things we wanted to do here is to have a lot of continuity in mouse movements, so that, for example, let's say I have, I don't know, that I should be able to do like the, one drag operation, right? Let's make this here, so that I can have something like this, and then kind of fill this with one drag motion, right? Or clear this with one drag motion, or have some really complicated pizza slice, right? And do something like this, and then copy this, and with one motion paste this to the entire row. So we wanted to have these like inter or cross component continuity, right? So that you can do in specific motions. And the juice system, or at least the component, the way it works by default, will not do this, right? It's basically every component will each either it will have its own like clickable bound, then it will capture the entire event, or it will not capture any events, and then you kind of have to capture it in some big level. And so what we wanted to do was, we had this thing where technically, for example, the slice is a component, but it actually has like some bigger system that will route the mouse events, so that it has the actual product logic, so that if I'm going to click this, right, just isolated, then this will be handled by the slice component. But if I do like a drag, then some of it will handled by the slice component, and some of it will handled by the bigger pizza or the bigger row, because it needs to be, for example, one single action, so that I can do this, and then I can undo one action and not three actions, right? So it has to be managed in different layers, I guess. So I guess a bit complicated to explain, but yes, it's using it is using the component system, but it kind of overrides it to create a lot of custom behavior. So yes,
amazing. Yeah, really impressive. Really impressive stuff that you've done there. I've never seen that in a juice plugin. So
thank you.
So a question from George is, what feature was implemented way faster than customers thought it would, and what was surprisingly complex? So are there any features that you thought were going to be very difficult that ended up being simple, or vice versa, simple ones that you felt were going to be complex? I can imagine.
Such a good question.
Yeah.
Do you have any specific example? I don't know. We go into such depths about everything that it makes this a difficult question for us. We were talking about this. Sorry, we were talking about this talk before. We're like having dinner and kind of discussing what we should talk about. And then one of the things that came up is that there are no like there's nothing that's not important when you're like very much like in love with what you're doing, in a sense. So everything here was giving an insane amount of attention. Like, even we're discussing the color coding, which maybe people kind of take for granted, like it's nice circles, nice colors and everything, but it took I don't know, a couple of months to come up with 16 colors, and then to come up with a general shade of blue for the background that would complement that. So even stuff like that, it was surprising. I was like, that's something that caught me off guard, because we'll color code 16 drums. What's the problem? try doing that. It's like the back and forward was crazy, and you end up changing shades by like a single point of green just to figure out if everybody can differentiate between two shades of green, and then the research around that. And then you have to build the system in the code because we want to reuse the exact same shade. So you can see in the plugin if he pops it up. So the hi-hat has a representation in color on the sequence area, and then it has a representation in color in the sample selection area in the bottom, like both here and here. So it has a lot of systems we made have several representations on screen. So we had to code that in a very intelligent way because it's, again, the same thing. We figured out this is something we'll be using for years. And we have to have this infrastructure that I don't need to like hand code like each color and placement all over again. We need to have like something that makes this operation very easy, and there's like a, you know, an easy way to kind of say, okay, hi-hat color, right? And then I can even send it to the JSON and change all the places where it's being presented at the same time. So I guess, yeah, that's a long answer, but stuff like that sometimes kind of catches you off guard because it's kind of like you pull on a wire and then you get this big ball of yarn at the end of it. You're like, oh shit, it's a way bigger problem than I figured out choosing colors, because it has ramifications all across our code base basically.
I have a couple of things that were actually more difficult than we thought. One of them is this little thing. When we move a slider, we have like a text box, right, with the values, and then when I stop moving it, it goes away. Or you can maybe double click and put in some value here. And this is surprisingly harder to do in Juice than you would think, because if you think about like a component, right, in Juice, it has a specific like rectangle around it. Like whatever component would be like this thing, or maybe the knob, you know, with or without the label would be a component, right? Just be a rectangle. But then we have these things that show up that are actually totally outside of the bounds of that component. They're somewhere else on the screen, and they show up only when this thing is touched, right? Only when you move this, or only when I double click to put in a value. And this is challenging because you need some architecture where things would be able to kind of post things almost like a pop-up menu, but they would do it without changing the mouse interaction, because the mouse is still on the knob, for example. So these kind of things are tricky to do, right? Because they're all over the UI. They're so basic. You need them when you're moving each of our sliders and knobs and things like that. But then you don't want something like the Juice slider. At least we don't want that, because the Juice slider has the value always visible. It's always in the rectangle of the slider, and it's really ugly. We wanted more something that's floating, like FabFilter and other like nicer companies would do. And that requires some thinking of how you structure things in, you know, both within a component, but then getting out of it, you know, whenever you want to do that. And same with other stuff. We have like floating windows, right? So for example, we wanted it when you open the About window, then, you know, it kind of draws on top and things get dark, but then, you know, you can kind of click anywhere and close this. So all these things are slightly more tricky than you'd think they are, because there's always something else that kind of needs to be considered when you do them. For example, you know, you open this, maybe you'd have a pop-up menu open and then you open this, right? Or maybe something is playing and then you open this, right? And this is actually still playing in the background, right? So, and all these things would cause really like small unnoticeable bugs in the UI whenever you try to do them. Like things would collide, and things would kind of work, but then, you know, the label would get stuck on the screen.
You'd get locked out of the plugin.
Get locked out of the plugin.
All sorts of weird stuff like that.
Yeah, because you're essentially, because every time you're doing something like this, you're kind of painting on the top component, and then you're sometimes taking mouse events from the actual things on the screen. and you want to, and then maybe something was just mid gesture right before. So there's all these like edge cases that you have to deal with, and these are like really simple things. These are not like the glorious things about the plugin. They're just like things you want to move a slider.
I was always taking stuff like that for granted being a user before I was a developer. I was like, oh, of course there's like a pop-up thing that shows the value, and of course there's like everything is nice and the knobs turn, and then you kind of go into the deep end of development, and you're like confronted with, oh, I actually have to make every single decision and stuff. If I don't decide, it's going to be some generic decision that was made for me, and then you're kind of missing out on giving your users you know, the ultimate experience, I guess, or the way you would see it. So it kind of tests your attention to detail. So yeah.
Fantastic. Tugrul asks, maybe it's silly to ask now, but if you were to re-implement, where would you like to start over? So is there anything that you built upon that, are there any parts of this plugin that you kind of cast your mind back and say, I would really like to do that over, or I feel like I improve on that?
Everything is perfect, right? Like, we're flawless. Like,
yes, no. We're all
Naturally.
refactoring bits of it. There's some uglier bits. There's definitely some things that I would, now that I've rethought this and I've solved a bunch of bugs. There's definitely a few things in the logic of the way the sequencer works, because this sequencer can do a lot more than what you see on screen, like a lot more. Some of these will go into features that we'll add, but some of this is just like internal tests that I've done, because this sequencer is like an abstract machine where each like layer in it can actually modify the previous layer. So it's meant for things like time effects and weird polyrhythms and things that are way beyond like even beat scholar. It's but that also, because it can do all these things, there's some really annoying complexity that I put in there that was actually harmful. That was actually causing problems in the development, because it was just like crazy ideas of mine that I had to have in the API, right? Because I thought that people would want to do such a thing, and then we were like, okay, this feature is there, but nobody would want to do this, and then sometimes the structure of this gets in the way, right? So one of the decisions, like such a boring technical decision that I made, I guess early on, and then reverted it later on, was I really wanted all of the sequencer to be based on something that you can do with value semantics, so that it can just be like very pure values that you could just copy around, and then the sequencer itself could just like modify everything by value, and it'll be like, so I thought it'd be like such a magical idea, and that idea failed in so many ways when we tried to do the thing, and I had to rewrite it, because it was just like and I was researching how to do this, like researching like all kinds of like concepts about functional programming and value-based programming, and I've spent a long time like in the rabbit hole of this, and then at some point I had to like stop myself and say, look, like there's absolutely no reason to do it like this. Like it's just like it's an interesting concept. I'm still interested in it, but it's like it's stopping me from actually putting features. So I had to revert it, and then there's still bits in there from that early concept that should probably not be there, because what it means that there's all these like layers the code has to go through to do something simple, like something we've just did recently. I want to say, when you want to like copy paste a bar, and the bar has a different time signature, and that sounds obvious, but it's not, because the sequencer actually doesn't, like the bars are actually not in the sequencer. They're like more of like a connected concept to the sequencer, because they're like more of like abstract timing things. Because I made this because I said that people might not want to have their their rhythm arranged in bars. They might just want to have abstract polyrhythms, which is still a cool idea. So a lot of these is now in my way because there's just so much you have to go through to do simple operations like copy one bar from this side to another side. So I don't want to go into too much like low level detail, but this is really there's been a lot of that. There's still are probably.
You didn't tell me these things. No. I should know stuff like this. I'm kidding. I actually remember that week where I was calling it out and he says, "Listen, I got to take some time and refactor some things in the sequencer." I think I went around. He was like giving me a talk of like, let's just let me do this thing, and I remember that. So, yeah. Yeah,
I mean, you always we now describe the thing in hindsight, right? But one of the things we know as a constant in our process is that sometimes we screw up and we have to go back.
Oh,
that's
for sure.
Yeah, like that's something we know as a constant, and the only thing we're saying is that let's make the process of doing that nice, so that whenever we do have to erase a bunch of our code or change it, then it's easy for us because, for example, we really for example, when we wrote the code, we've reread it a bunch of times to make sure that it's understandable, so that when we remove it and change it completely, then we know what we did, right? Because that's sometimes, right, that's pain that you run into, right? You write the thing, whatever, you prototype the thing, you write it ugly, and you leave it ugly, right? And then you go back to change it, and you're like, oh my God, I just have to remove the whole thing. This is horrible.
But you're the way I see it, like you're gonna screw up anyway. Yeah. You might as well get it out of the way quick.
Exactly.
You might as well like hurry up and mess it up, and then you can get it right. Because it's really that you got to look at the fastest example of your idea, and then like see if it sticks, and if it does, you're like, okay, I'll figure out how to make this work eventually. But if you don't do that, I guess like you can get stuck for an extended amount of time, then end up with something that's not good for you. So it's bad for developing quickly.
Yeah. I think there's a saying, if you're gonna fail spectacularly, or something like that.
Yes.
So, wow, we had some amazing bugs in this software. We had some of them. It's so much fun because it deals with timing, and timing can mess up your head like big time, So, and the opposite, like we added just before releasing, we added the ability to slice beats up to like 42 pieces, which is crazy. You can make like oscillators out of bass drums because of that. Like I have a preset that the kick is just playing bass notes because it's rotating so quick, and that's also like the other side of that. That if you make the system so sometimes stuff, I don't know how to describe it, but stuff it's not supposed to do that. You know what I mean? Like you kind of discover something, and then you're like, wait, but this is super cool. This is actually like something usable. So. I really want to show it. Do you mind?
Yeah.
So it's called now it's just about the time where I completely forget where it is. No, this is terrible what I'm just oh man. Dead air. This is great. Give me 1 second. I'll say something.
While he's coming up with this, there's actually a related question from Jas, who asked, did you use oscillators and noise based for sound, like a sound generation system for some different drums in the program, or is it all resampling based?
The version that's out is all based on samples, but it's samples that some of it is stuff that it's all our original samples. So some of these samples were that were done by Yoni Meltzer, who's a good friend of ours, who's a very good sound designer, and so some of the stuff is stuff that he synthesized. right? So he just created something from scratch using a bunch of layers. And there is actually a synth engine in the thing which we thought we might use as extra layers, but it's not there in the product because at some point during the development we decided that like the really the big thing about this is the sequencer. So even though the sampler here is pretty cool, like you can even load your own samples and stuff like that, the real big thing you can do with this is actually use MIDI, because this thing sends out MIDI and can control hardware and other VST plugins and everything, or can drag MIDI patterns. So at some point we decided to just say, okay, let's make the sequencer area amazing and keep the sampler relatively simple, even though it's still functional and still has effects and
it's enough to get you going really quick. That's what we wanted, because I'm just gonna play this because I looked for it for so long.
Let's solo the kick.
So these are this lane is just individual kick drums, but they're being played so fast it sounds like an oscillator. And it's something that you kind of look at it and you say, well, this can be like, it's a bug or a feature. It's a classic one of those where should I limit the amount of slices? But then you come up with something like this, and you're like, I guess not. I guess like let's just do it 42 because it's the answer to everything.
We have a question from Sudara. Hi, Sudara, who asks, now that you've shipped, have customers come up with any feature requests that were unexpected or that you hadn't thought of before?
So we got a lot of feature requests after releasing this, which is actually kind of awesome because people like the idea and they have all these like creative concepts around this. A lot of these were things that we'd probably we thought about and we'd probably do, and we are doing some of those in an update. There's just an update today that we just finished, but to me the biggest feature that everyone has been asking for, which caught us completely off guard, is to have randomizers, which because we talked about this during development and I kept thinking I don't know. I never use randomizers. So are people really going to use those? And then everybody ask us to put in randomizers.
It's like half the world is apparently creating music in a completely random way.
Yeah.
From our perspective, people are like, this is great, but it should have probability engines and randomizers and stuff. I was like, okay, I guess, yeah.
Yeah. So now we have to actually add randomizers in there because everyone are asking.
Oh, we're just talking about it today. We're going to do it in our way, we try to do all these things. It's not going to be completely random. We have to have this musical idea of what would be both random, but then will be in context. Because you can very easily, combined with the pizza system, you can go blast off into non-existence in terms of rhythm. So you got to have some sort of control over it, so it's actually usable and not just random noises, which is apparently also what people really want.
Yeah. It'll be the genre creator. It'll create.
Yes.
We can only hope. The future of pop is just random beeps in some order.
So I'm conscious of our time. So I think it'd be a good time for us to wrap up. Is there anything else that you wanted to touch on that we haven't covered already that you feel would be cool for our audience to know about? Or anything?
Yeah, just it's if you liked this product, we have a free trial. You can try it. You can go to modalix.com and see what we got, see what we have to offer, and I'm always around on the Audio Programmer Discord talking about whatever random tricks to use Juice or weird build system problems or whatever it is that we run into. And also we have our own Discord. That's not like a coding channel, but it's like a community Discord around our things. Yeah, come chat with us. you know,
Yeah, you can send us feature suggestions. We're live on there all the time. Unfortunately, like we barely sleep, and it's great. No, I just want to say I'm relatively new to these sort of communities. First of all, like thank you so much for having us. This has been a blast. I'm guessing,
awesome.
like, and hoping like we have other opportunities to chat. And you know, it's a pleasure to see people so active and so willing to help each other. I've known these community and your community specifically, the audio programmer, like through Eyal over the years, and I've watched the content, but just being on here and seeing all the cool people talking to us and asking questions really feels great. So thank you for having us.
That's awesome. Thank you so much for the kind words. And yeah, definitely check out Modalix.com, get Beat Scholar. It's awesome. Can you give us any clues or any hints on what the next product might be? Any ideas? Or is this...
Not yet. What we do want to invest a bit in Beat Scholar, so we have a lot of like major features that we want to add. So just to give you an idea, just now we finished an update with a MIDI effects component for Logic. So that was one feature, and we've added like a bunch of little features along with that. And we're gonna invest also in an iOS app, iOS app.
Yeah.
Anyway, which is something else that we've been requested. So we have a little bit of time to get this happening, because we one of the things I've learned from other amazing people I've worked with, like Steve Duda that you've mentioned. Steve Duda, you know, kept improving his products for years, and that's something that I loved about him, and that's one of the things that made his products so timeless, because they weren't just the way they were released; they were like a sequence of features being added over many years.
Yeah.
So that's something we want to, you know, do for, at least for a while.
Yeah, but looking more far into the future, it's, I guess, more stuff that has to do with music composition and taking that sort of side of things and making it kind of flow state process and you know, keeping you like in that sort of space instead of a technical area. So
yes,
that's the area we're going to do. Maybe for bass, for
Alex
harmony,
Doll.
for
What about a doll?
maybe we'll see.
Yeah.
I have a Figma file right here.
Yeah. Or at least a free pizza with your purchase of
Yes.
Beat Scholar.
That's our next collab.
Cool. Thank you so much, Or and Eyal. Thank you very much. And yes, check out Modalix.com. And fantastic to hear your story, and just anxious to see where it goes.
Yeah.
So, yeah. Rachel, unfortunately, isn't able to do DSP Corner today. She had to unexpectedly jump off. So DSP Corner is going to be something that we will film a little bit further down the road and release. So Rachel isn't with us for the rest of the meetup. But with that, just wanted to remind you before we jump into our next talk about the Audio Programmer Discord. So we have a community on Discord, as Eyal mentioned, and it's been a great place for discussion about all of these types of things, and really interesting discussions about build systems, about DSP, using Juice, Max MSP, all aspects of audio programming. And you can join us on the audioprogrammer.com/community. And with that, we're going to shift gears now into a different world, where we're going to talk a little bit about spatial audio, and specifically spatial audio in the browser. And if you are familiar with the metaverse or with spatial audio, you know how important it is to have quality audio and quality spatialization in your listening experience, whether you're playing a video game or whether you're in some type of metaverse, talking to people and interacting with them. So we have the team at Atmoky here, who are going to talk a little bit about that space and talk about some of the challenges of that space, and also a little bit about the exciting stuff that they're doing with 3D audio and spatial audio. And with that, I will turn it over to Daniel and Markus, and I will let you take it away. So welcome.
Yeah. Hey, thanks for the intro. I hope that my sharing did already work. So
yes, you're all good.
Okay, perfect. So we just prepared a few slides so that we can show you a bit what we are doing. And first of all, we are really happy to be here. So thanks for having us. And as you mentioned, Daniel and I are here to tell you a bit about atmoky and our journey so far, and also what we have just planned for the future. And first of all, so we are sure that the future of audio is 3D, because that's what we are all about. So 3D or spatial audio. And for all who aren't really familiar with the term, we have here a simplified explanation. So as you know, in the real world or in natural or realistic listening conditions, our ears as the sensors and also our brain allow us to localize sources relative to us with a certain direction and distance. And over time and over listening to just a lot of different environments, we have also internal references for how it's going to sound in different rooms. For example, we can always assume how a bathroom will sound or has to sound. And that's basically all what you can do with spatial audio. You should be able to recreate experiences. And we would like to give the listeners the sense of being actually there in the room, at least acoustically. And that's what we mean by true spatial audio. And in order to make such an illusion or recreation a reality, there are just certain aspects that you need to do right. And we learned about those parameters that are crucial for true spatial audio during our time at university at the IEM in Graz, and where we worked both as researchers, and we also defined a few of those parameters and tried to build tools that build on that knowledge. So the parameters that, especially when talking about spatial audio over headphones, are three that we believe are the most crucial or the most important. The first is quite obvious. You have to do the direction right, meaning that the elevation or azimuth, or let's do it in Cartesian coordinates, you just have to get the direction in the relative to you as a listener right. And the simplest way to recreate such a direction would be to record with microphones in the ears, which then is called something like binaural audio. That's not really generic, doesn't allow us to recreate or to produce spatial audio. Therefore, there's the model of your ears and your torso, which are the HRTFs in this case. So the head related transfer function, they encode time differences, level differences, and also direction dependent filtering. I'm sure most of you will know about that, but we can also dive a bit deeper into that a bit later. And let's say HRTFs are matched and you can make the direction, then you need to do something in order to get a externalized sound image. And that is probably so the only way and most convenient way is to do it with reflections or some sort of decorrelation of the ear signal. So every real room or environment has reflections, and the direct to diffuse ratio is also the great indicator for distance, which means by controlling the direct to diffuse factor, you can just get distance and externalization, and that's also related to how your ear signals are correlated, or in a diffuse sound field they are decorrelated. And one really important thing when talking about spatial audio over headphones is that it has to be reactive. You have to do dynamic binaural rendering, otherwise it will be something like a stereo effect probably. And to come up with that, you also need to have really low latency, because as a listener you can always distinguish if latency is too high. And like dogs are moving their ears for better hearing, we humans are moving our heads, and this helps us a lot, especially if you want to distinguish sources that are coming from the front or from the back. So that's what we believe. I'm sure that a few of you will see that personalization is not really in there. And yeah, we know that it can be important, but there are also a lot of studies that show if you have good generic HRTFs that are high fee, meaning that you also reproduce low frequency content, if you have room and spatial reverb on it and you have dynamic rendering, then the personalization makes just a few percent of maybe immersion or that you could make it better. Yes. Okay. During our time at university and also after that, we took that knowledge and then came up with a perceptual optimization strategy that helped us to come up with a spatialization and rendering engine that can reduce the complexity that's typically involved in spatial audio by let's say 89%, while keeping the perceptual quality really high. So here are some examples from listening experiments for different room sizes and also for turning head tracking on and off. And basically what this shall show you is that when just taking perceptual optimization or favor that over a physical modulation of what you want to hear, you can reduce complexity a lot, and that makes spatial audio also possible on platforms with just not that high amount of computational resources. Okay, we strongly believe that perceptual quality matters when it comes to audio, and we also like to stress that spatial audio is not always spatial audio. So there are, especially since it became somehow native to iOS and to the Mac apps, but also before that and in the browser. So there are just a few marketing terms that are now there with spatial audio. That's basically just stereo panning or only distance attenuation. So yeah, for us, true spatial audio needs to involve all the three parameters that we or I showed before. Okay, you may know from us that we did something before we did atmoky. As I mentioned, we've been at the IEM, and we tried to bring there some tools to the community that can help to build and produce spatial audio. And I think now the IEM plugin suite is one of the most heavily used toolkits for producing spatial audio. Daniel was heavily involved in making them happen. And there are just a lot of different tools. We have something for spatializing, for maybe even dynamics. You can do some conversions. You have a loudspeaker rendering approach that's based on Alrad, a binaural rendering engine, and just a lot of different tools. And those tools were obviously the basis or the foundation for what we started. We of course heavily extended that and also did our own research and optimizations. But in general, the functionality and the tech stack that we have at atmoky covers pretty much the entire production chain. So we have, just also stuff for recording and upmixing and other conversion tools. But right now we are strongly focusing on the spatializer, on adding some effects, reverb, and on the rendering, and so for rendering to headphones and to various loudspeakers. And we also follow our vision, which is to bring true spatial audio to the people and promote also workflow that fosters creativity. And with that in mind, we came up with two products that we have released or are releasing right now, or that we are promoting or pilot testing, let's call it like that. And that's the web SDK and the native SDK. Where the web SDK is really branded to be the audio engine for the metaverse. It's built in WebAssembly, and just works with a lot of different streaming services with voice chats. And what was really important to us is that's highly reactive to user input and to interaction with your avatars or whatever game logic. And the other thing is the native SDK is optimized for mobile and desktop applications. And the cool thing that we did or tried to do is that both SDKs follow the same concepts for developers. They give you the same experience as a user over different platforms, and also they include the same tools for the sound designer. So yeah, if you decide to go with our SDKs, then the experience as a developer, user, and sound designer should be the same across all platforms. Yeah, for this talk and also for what we are doing, we strongly focus on the web. And yeah, we asked us a few questions before we started that, or had good reasons to go to the web at this stage. So we experienced a general trend towards web applications. So a lot of desktop applications now only run in the browser or additionally run in the browser, but we strongly believe that this trend is going to last. However, we didn't really see or hear a lot of spatial audio applications and solutions in the browser yet. And so the questions that came up and that we asked us were probably if it's too hard to use, or if the experience is too different across browsers. Maybe it's even too hard to produce or design audio for it. And maybe also the iteration circles could be too long. So going back and forth between sound designer and web developer, product manager, and so on. And yeah, those are a question that we try to answer with our web SDK, or to overcome at least. Yeah. And another reason why we went for the web SDK now is that it's with WebAssembly, it really makes a lot of sense because it's technically feasible. In general, spatial audio is on the sweep. So at least until I think 2020 when Apple released it. And another thing that pushed us towards the web is obviously the trend or the buzz about the metaverse, whatever that will be or it's going to be. If it's going to happen, then sound is definitely considered to be a crucial part of it, because there will be no real immersion if one of your major senses, like hearing, is just off and doesn't fit to what you're seeing, or just isn't realistic or natural. So that have been the reasons for us to go to the web to build our web SDK. And the features that we are having now in the web SDK allows you to spatialize voice and any sound objects in all 3 dimensions. We believe that you can really spatialize a really high number with our SDK. We have a reverb engine that is adjustable, can help you to build rooms and to make certain effects go from a big hall to a conference room or whatever. We have an externalizer engine in there and brand new hot and occlusion feature, but I'm probably going to show you that later, or Danny will talk about that. And as mentioned before, dynamic rendering is crucial, so it's quite obvious for us that it has to be in there. And we also decided to render directly on the client to keep latency really short, and that are the basic features. Which brings me also to the USBs, which are quite interlinked, I'd say. So as mentioned before in the questions that we asked us, our stuff is cross-browser consistent, meaning that it supports all major browsers, sounds the same. We build on high performance in WebAssembly. Also, our algorithms before we went to WebAssembly are highly optimized in terms of the perceptual quality. We integrate with modern web interfaces like Free.js or Babylon.js. We support various WebRTC voice chat or streaming providers like Agora, LiveSwitch, or Twilio, for example, where we also offer integration examples. And due to our choice to render directly in the browser and not to send the tracking data or movements to the server, and also do the mixing of audio on the server, we have the lowest motion to phonon latency with our SDK. And the last thing that's here on the slide are the developer tools, which are really dear to us, because those are the tools that help to bridge the gap between developers and sound designers, so that you really can, just shorten integration times and cycles a lot. And that means that now Daniel will take over and show you how to work with the Web SDK and give a few more examples. And I think I have to activate or let you take over my slides.
Yes, please. So, hi everyone, I'm Daniel. I'm in charge of development and all the programming stuff at atmoky. I'll give you a short overview and some code examples of, and which should show you how to use the SDK. So let me see if I can control the slides. Yeah. Okay. Cool. So before we dive into code, I want to show you some basic concepts and maybe even something about the Web Audio API in case you aren't familiar. So the atmoky Web SDK is a module for the Web Audio API, and it works in the audio context, which comes with it. In the audio context, you generally have a couple of, or even many audio nodes. You can connect them together and eventually send them to the destination, which is basically the audio sync of your browser. So the sounds get heard after that. And you see here we have, for an example, 3 audio sources. Each of them has a gain, a panner, and then they are combined, summed together into the audio destination. And you see it can get very crowdy once you want features like a reverb send bus, because you need an extra gain for every source to control the send level, send it to a reverb node, and that output back to the destination. So it can get very crowdy, and it's fun to play around, but it costs a lot of time to set it up, especially if you want to recreate the same experience or a similar experience every time. So you mostly have this setup right here. With the atmoky Web SDK, we provide only a few classes which you can use and reduce that complexity. For example, we have the source class, which wraps around audio nodes you can use as an input. And these audio nodes are sent to our renderer class. The renderer takes care of spatialization, of a spatial reverb, and also takes care about the logic behind the attenuation curve. So that means basically when a source goes away from the listener, how does its volume change with that distance? That's all inside of our renderer class. And with it also the listener, which is the main, it's basically the listener of the scene. Everything is rendered in relative to the listener. So each source has different properties like gain. The position of the source can be changed. You have a reverb send level you can set. And with today's release, you even get occlusion. So you can simulate a source behind a wall in a room while the listener's outside and stuff like that. And the listener, of course, has also a positioning system. And for the reactivity, the listener can look into different directions, and the sound field is rendered accordingly. So the next slide is code, I promise. We actually provide you with 3 main classes. That's the manager, the renderer, and the source class. The manager is here to set up an audio context, because you need to add our module into the Web Audio API's audio context. This is also managed by the manager, hence the name. It also takes care of loading the correct module, because there are browsers outside which don't support SIMD in their WebAssembly implementation, and others who do. And according to that, at runtime, we decide, shall we load the SIMD optimized one or the non-SIMD optimized one? Okay, once the audio context is prepared, we create a renderer of it. We tell it the number of sources we want to have. And the renderer basically is a remote control to the WebAssembly backend in the audio worklet. That's basically the rendering backend of the Web Audio API. And the renderer can also create sources for you. And with those sources, you can control and set specific properties on it. Okay, so it's time for code actually. So it's, for me as a developer, quite easy. I'm not sure if you think the same, but I've got another trick in my pocket for later, but let's dive into this example for now. So the Web SDK is an ES6 module. You basically just import the classes you need here, manager, renderer, and source. Then you have some placeholders for the renderer and the source we want to use later. We create a manager in the audio context. The manager is a atmoky class. The audio context is built into the browser. And we tell the manager to prepare the audio context. And once that's done, we do like our setup code. So the manager is told to create a renderer. We got that in line number 10. We connect the renderer to the context audio destination. And we don't do this automatically, although in most use cases you will have that line of code. But for example, you could have a use case where you want to have a dynamic processor in between the spatialization and the audio playback. Then we tell the renderer to create an audio source. We set an input to it. And the input in this example is just an oscillator which plays sound. And you actually can use every input you have or every audio node in the audio context. So it can be like a sound creation source like here. It can be an audio player where you load audio from a file, or even a WebRTC media stream you get from like a voice communication provider. And in this example, we set the source position to XYZ coordinates 3, 2, 1. But with the source, you can do even more. So you have the input setter. That's obvious, also the position, but you can change the gain in both linear and in decibels. Same with the reverb send. We got a spatial audio reverb engine in the renderer, so you get true spatial reverb. So not just stereo or something, but it's really immersive reverb engine in there. As I said, with today's release, the occlusion. So in this case, like the source could be behind a hedge or something, not sure. And you have something like the attenuation curve index, because you can define several attenuation curves. And we will see that in a later video where you can group sources together and assign them to the same attenuation curve, because sometimes it makes sense to have like the communication participants to hear over a further distance, and you can define like smaller effects in a vicinity in a specific area of your game. And the attenuation curve, it's basically a piecewise linear curve, which on the x-axis you have the distance of a source to the listener, and on the y-axis the volume you want the source to have for a certain distance. And you can imagine a piecewise linear curve is quite hard or cumbersome to define purely in code. And that's why we came up with developer tools to give the developer or the sound designer something they can use interactively. And let me show you like an example. On the right side, you got our source viewer. It's basically a pop-up window which pops up, uses all the information stored in the renderer instance, and you can see where sources are placed visually. You can turn around, see how the listener walks through the scene if you have implemented like a game-like movement system in there. And this, even if you don't have any visuals in your application, you can open the source visualizer during your development stage and check if everything is spatialized to the position you would like to have. Okay, let's get to the attenuation curve designer. That's also a pop-up which you can use during development. Of course, you can get rid of that during your production phase, because it is only necessary to use it or to give the sound designer the opportunity during the dialing in the perfect sound process. So the attenuation curve designer, let me start the video. I hope it works. Nice. So on the x-axis, as I said, you see the distance of specific sources to the listener, like the congas here are very close and the river sounds are further apart. And I should be able to set the audio. So for example, in that movement, I simply dragged a curve with a piecewise linear attenuation curve, a point of that curve, and you saw that the river sounds, which are further apart, were now way louder than before. And that tool lets you export code a sound designer can send to the developer, or the developer can just copy and paste it into their production code. And now the attenuation curve is updated, because no one wants to set those points like in code. It's not really fun. Okay, let's see if we can get to the next slide. Yeah, okay. So you saw we simplified the setup in terms of number of audio nodes you have to create. But still, that piece of code we have here is basically full of boilerplate code, because of course you need a renderer, of course you need a couple of sources, you will need a manager and an audio context, and do all that setup here. And we even want to simplify that. It's not a lot of code you need here, but we thought it can get better. And this is why we came up with our audio scene builder. Once I get to the next slide. Oh yeah, here, okay. And all that code can be reduced to simply a one-liner, basically, next to the import new audio scene. Here you get a config file. It's a JSON in that particular example. And you can even pass options for the audio context. You don't have to, but you can, for example, in that example. And it's quite similar to OR and EL's workflow of, hey, just use this JSON file, dial in some numbers, change it, and you see the results. And it's quite fun to see that it's not only used in the web, like in our web SDK, but also during plugin development. And this should speed up the iteration you have in your typical development workflow quite a lot. So what you of course need is the JSON file. You see it here on the right. It has a list of sources. In this particular instance, you have like one source. It's a shaker. You tell it whether the path is. It's an MP3 in that case. The type of the source is an audio file. So with that comes also a little some lines further down the road. There is should stop playing and looping. So these are particular properties you have for an audio file, and you have an initial position of the source, and also parameters like reverb send. And you can also add their occlusion or anything else. So next to it, you get the attenuation curves. It's only one here because not so much space on the screen, but you can define as many as you like. Same with the sources. So, and this file doesn't need to be a JSON file. It can also be a JavaScript object. So you can have a separate file holding this object and tell the sound designer, hey, if you want to change the experience, use this file, change the numbers, press refresh in the browser, and it should work. So here, like a workflow outline, we heard from a sound designer that their workflow was very cumbersome because they had to create new sounds, send it to the developer. The developer had to implement it in code, compile it, send it to a staging server. The sound designer opened the staging, the app, and found, okay, there he or she has to make some changes. And this iteration is like one iteration is a day or even longer. And we want to make that iteration circle way shorter. So our workflow or proposed workflow would be a sound designer is in his or her DAW. He or she uses our audio plugin, which allows for specialization of sound sources the same way as in the browser. So he or she can listen to the experience, even though it doesn't have to be code like JavaScript code, a TypeScript code, or anything in the browser. And once he or she is satisfied with the results, export the scene, export the audio, JSON file and audio files sent to the developer. Developer drops this line of code, new audio scene config.json, and maybe puts it on the staging server together with our developer tools. So the sound designer could dial in the attenuation curve parameters, send them back to the developer, and we go to deployment and have a finished web experience in hopefully a very, very short time. Okay, and that's basically all I have to say from the development side of things. Back to Markus.
That's not true. That's not true.
Okay.
No. Maybe we can do the last part together, or I start with it, but you can just jump in if something comes up. So you probably ask yourself what are the actual use cases for our spatial audio web SDK and also for spatial audio on the browser, and we also had to think about that, because as mentioned before, there aren't really that many applications in the web to use spatial audio, at least not as we intended it to be used, and therefore we came up with our own demo, which is here seen as a quick screenshot, and we tried to put all the use cases that we could imagine on this map. But I will probably walk you through the use cases one by one. One use case that's not covered is obviously gaming, because our entire demo is something like a game where you can walk around and explore a scene acoustically, and other use cases that come to mind is to use spatial audio for virtual meetings and for social audio. There is this thing called binaural unmasking or cocktail party effect, or however you might call it. If you listen with both ears and you have a spatial audio representation of the scene, you can just hear people better or understand them, and it's also a nice thing to reduce listening fatigue if you're having long meetings. And one part of our demo is this meeting area. I'll try to unmute it, and so that you can just listen to it, how it's going to sound in our demo.
Seems like it even works in the browser.
Yeah, it does.
Cool.
They even made an interactive demo.
Fresh.
Shall we jump in?
Definitely. Can you send me an invite?
Sure.
Cool, see ya.
Hey, I was just talking to Chris about
Chris?
atmoky's spatial audio SDK.
Yes, seems like it even works in the browser.
Yeah, it does.
Cool.
They even made
I think you get it. That's fresh. The use case for the meeting scenario. Then we have a thing that's called the big hall, where we use just a different reverb engine, and that room is just intended to show that you can do concerts, you can do virtual events, you can make some sound installations. And we are also actively looking for other artists or sound designers that maybe want to compose something for a big hall, or just to present the work they did. And again, here I'm going to play you the quick demo. Okay. And another use case. So there are also some trees and birds on our map. Is when you just want to escape a hard day at the office, or just want to have something that's more natural or relaxing. So in our demo, we put some trees, birds, to also show off the 3D capabilities of our web SDK. So the birds are somewhere in the trees above you, and there is also a river that you can hear in the distance. And again, the playback. Okay, something that I forgot to mention. This probably works best on headphones. So it's intended to be listened to on headphones, because it's binaural audio.
Yeah, I think we should have said that.
Yeah,
but it's on YouTube, so scroll back like a minute or something, get your headphones, and you get the experience.
And it's great that you are talking right now, because now there is your newest feature, the occlusion. Maybe you can tell us something about that.
Okay, so in a first version of the demo, we simply had those rooms, and once we entered the rooms, we simply muted all these sources which are outside, and vice versa. So with the not exclusion feature, but occlusion feature, we wanted to simulate how a sound would sound like when it's outside a room. Like Markus is sitting right next to me behind this wall, and he's all mumbly and very dampened sounds. And basically, we did the same here. Once you're in the room, for example, the bongos you will hear in a second will be lower in volume and more dampened, like a high frequency roll-off. And the same once the listener is outside, and the big hall concert audio sources will sound similar. So let's give it a try. Yeah, and the cool thing is it's just one value you have to dial in. It's between 0 and 1. And you can bind this together with like your game engine. Like if you shoot rays and you see, okay, this sound source is actually obstructed by a wall or another object. So you can define like a value for each wall, add it up to the maximum amount of 1 in that case for the occlusion, and you very quickly get the experience of a sound source being shielded. And the cool thing is that happens after the reverb send. So the reverb will still be bright and have basically the same reverb send level, no matter what occlusion you have. And this makes it more realistic, of course.
Nice, which brings us to the what next, which can also cover Daniel, I think.
Yeah, I can. So let's do reverb zones last, because that's like my favorite feature I want to talk about. We from the audio world have a very strange coordinate system, I think, with the x-axis pointing forward, the y-axis pointing to your left, and z pointing upwards. I know everyone who does OpenGL or even in Choose with x, y going in different directions will say, oh man, we are crazy. For now, we have it that way. So we know it can be problematic for different game engines. Even with the game engine we use in the demo, we have to negate and switch out coordinates. What we want to add as a feature here is like you can say, okay, I'm coming from an OpenGL world or something else, and we do the conversions internally for you. Also big thing for maybe for sound designers and for example, especially for the workflow behind workflow with sound designers and developers are the DAW plugins we want to have. So we want sound designers to create those experiences in their DAW, so they can adjust effects or compression or anything else before they export the sounds and listen to it like a monitoring plugin in the DAW they have. And also like the ability to export those, to export those scenes you can then load with the audio scene builder. Then right now we only output binary audio signals, so you need to use headphones. It of course also works with loudspeaker playback. For example, here on my laptop, the sounds seem to come quite far left and far right from the actual speakers, so it gives the illusion as well. But what we want to provide is loudspeaker rendering, so you have like a rendering for stereo, but also one for 5.1, 7.1, all those standard layouts. And now let's get to the reverb zones. Right now we only have one reverb you can use. And of course, if you want to have different spaces, like a small room coupled to a bigger hall or bigger concert hall next to it, you want to have different reverbs. And you also want them to only be fed by sources which are in that room. And this is what we want to accomplish with reverb zones. So if you create one sound in one room and another in the other one, it doesn't depend on where the listener is, but where the sound is. So in earlier game engines, you had the problem once the player goes into a big room and someone like shoots a gun or something in a smaller room, you get that cathedral effect, but it doesn't make sense because the actual sound is in a different room. This is what we want to provide here, reverb zones which are source dependent, basically.
Nice. So that brings us to the what now. So also as a please note that I'm not sure if the sound from the demos or clips that I played back for you really came across as 2-channel or as binaural audio. So we tested it in Zoom and it worked, I think. So I'm not sure how it's going to sound in the YouTube live stream, but that brings me to the thing that's most important to us, which would be for you to check out our demo. It's public available. You can test it, explore it, and also can test it with voice chat integration if you want. And it would just be great to get the feedback of the community, because it helps us just to improve. Also, we think that there could be a few projects that benefit from spatial audio, or if you have feature requests, it would just be great to get in touch, have a discussion, and to see what we can build and where we can integrate spatial audio in the future or in the even upcoming weeks. So we are up for pretty sophisticated solutions, and also want to get some fun out of that testing phase and integration phase. And I think that brings us to the end, which is the slide where you can get some resources. So you can check out our docs, our webpage, and also the demo, which is demo.atmoky.com. And thanks again for having us, Josh. And if there are any questions, we're happy to start a discussion.
Absolutely. Thank you very much, Markus and Daniel. Fantastic presentation. And we do have 2 questions so far. So if anybody else has any questions, please feel free to ask them now. One question is from Ismar, who asks, for occlusion, I see there's a single float that serves as an occlusion factor. Does that cover most cases, or are there cases where you'd want to occlude based on a 3D shape?
The occlusion gave me some headaches, because I had to choose between like a very sophisticated model where you can dial in all the parameters you want to have, and like the simplicity to use it. And I thought, we don't know what game engine you will use, or even if you have your own one with ray casting and checking what object is between the source and the listener. And for now, we thought the easiest way is to have like a 0 to 1 ranged value you can use. And you can even change the mapping basically on your side. So you can lean it towards the 0 or more towards the 1 as you go, and have your own system behind the occlusion. So our WebSDK is not geometry aware, because with that we would have you to rely on our physics engine or the object models in there. We wanted to make it as usable as possible in every kind of framework you want to use. And we are also currently in the integration phase for most of those platforms. For example, 3GS will be the next demo. We have projects with Play Canvas. Our demo is written with Phaser.io, Phaser.js, something like that. So that's basically the long answer to that question. Sorry about that.
Ismar, if you need any more clarification, please feel free to let us know. And he had one more question, which was, what kind of speakers and / headphones does it work on? But I imagine it would work on any speaker or headphones, right?
Yeah. So I think it's a big debate what headphones you could use or you should use. In research, you often see those, what are they called, AKG K1000. So they are basically 2 rectangular shaped things you have in your head and with a distance to your ears. I think the same thing is true with the Valve Index speakers. They have a distance, so you don't get the feeling of you're inside your headphones, because you hear the real room and have like this augmented feeling in there. But most of the time we have either like AirPods from Apple, it works with them. We have the usual studio headphones like the DT770, the some AKG models. So it works with everything. You get, of course, a different tone, but that's also true for music playback.
Yeah.
Yeah.
But in general, it's really interesting because it's also what you are expecting as a listener. So I think we have learned that if we put on headphones, that has a very specific sound. So headphone sound is always quite different to listening on speakers. And I think also for spatial audio, you can definitely learn it, or if you experience it a few more times, like we, for example, did during research, where you listen to the same spatial audio scene and HRTFs like 1,000 times, then everything else that comes out of headphones seems to be a bit off. So yeah, in general, it's not depending on hardware, but yeah, we are aware that there are certain other aspects like room diversion effects. If you are sitting in a different listening room where you as a listener would expect to be specific reverb or reflections, and you are simulating different ones with your spatial audio playback, then it also can seem to be a bit off. But yeah, that's all about expectation. And yeah.
Nice. Cool. Thank you very much, Daniel and Markus. Great. And where can people, there is one more question that just came through. This is from Jas, who asks, does the SDK deal with psychoacoustic phenomena? Not sure what that is, but maybe you know.
In the sense that it covers, yeah, HRTFs and ITDs and ILDs and interaural cross correlation. So that sort of stuff is inherent, because yeah, our rendering is based on using HRTFs and also three-dimensional reflections and reverb engines and externalization. So in that sense, definitely yes. I'm not sure if he or she was referring to maybe Doppler effects or something like that, but yeah.
Okay.
What we can add to our binary rendering is that we want to have like a rendering engine which is as transparent as possible. So there are many renderers out there which have a certain sound that can be good, but can also be bad, especially if the sound designer has a different sound in mind. Ours, we optimized it in a way that it's so-called diffuse field equalized. So if you listen to all the directions it supports, it's basically flat. So you don't get any coloration you don't want. You of course have direction dependent coloration, because that's what our ears do. But it should be as easy to use and not add too much coloration.
Yeah. Also very interesting. I think that lots of binaural renderer come from where you intended to render for loudspeakers, and then people just make a virtualization of that speaker setup. And if you do that, obviously you always have the room and also some sort of speaker characteristics probably on it. But the real cool thing is if you build a renderer that has the goal to output the best possible binaural signal, then you can make a lot more tweaks and make it way more efficient and also more realistic in terms of when you rotate your head. But if you virtualize a speaker setup, and even if you are in the sweet spot of that speaker setup, due to the time differences of the speakers, and if they are not on the same radius, you always have some comp filtering going on if you rotate your head. And if you just go for binaural from the beginning, then you can make a lot of quality improvements here.
Amazing. Cool. Thank you very much, Daniel and Markus.
Thanks for having us.
Yes.
Thank you.
Thank you. And thank you as well to Eyal and Or. I think Or had to run away.
Thank you. That was awesome. I really enjoyed this.
Yeah.
Thank you.
Really a lot of fun. And big shout out to Rachel. I hope everything is okay with her as well. She had to run early, unfortunately, but we'll be seeing her for sure on our next meetup, which is going to be the 11th of October, which is every second Tuesday of the month. And we have some special guests already planned. Once again, if you haven't joined our audio programming Discord, be sure to join us. You can join on the audioprogrammer.com/community. And with that, we'll be signing off. Thank you very much to all of you and to everybody who's been watching. And if there's nothing else, I will see you all next month. Cool. All right. Thanks, everybody.
Bye.
Have a great evening.
Bye-bye.
And thanks again.
You too.
Speak soon. Cool. We are offline.
Cool.
Thank you so much.